Good day and welcome once again to Lesson 5. In Lesson 5, we're going to be looking at root cause analysis. Root cause analysis. My name remains Engineer Sonny Ogboji, and I'll be leading us through some discussions on root cause analysis. To start with, what is root cause analysis? Root cause analysis, RCA, as the acronym, is the process of discovering the root causes of problems in order to identify appropriate solutions. Most engineering problems present themselves via one symptom or the other. And if you are not careful, you might be treating symptoms without really addressing the underlying causes of these symptoms. For instance, for example, you have a situation where a bearing is collapsing. A roller bearing is collapsing. Every week, as you come for maintenance, you open your bearing housing, you discover that the bearing has collapsed, the cage has collapsed, all the rollers have scattered, they are in the housing, and they are mixed with your grease and everything. You replace. Next week, you discover that you have the same issue again. Now, if you are the type that want to treat symptoms, you might just be changing bearings. But this comes at a huge cost, and nobody is going to listen to you after a while. Appropriately, you need to investigate what is the cause of this frequent collapse of bearing. Why are the cages given? What are the underlying factors? What could be the cause? What could be the reason why the bearings don't last as they are supposed to last? And that attempt at investigating or isolating the cause is what we call root cause analysis. It assumes that it is much more effective to systematically prevent and solve the underlying issues rather than just treating the ad hoc symptoms. Because the symptoms may change, they may get complicated, they may move from one pattern of manifestation to another. So if you are following the symptoms, you could be far away from the root cause, and it could mess you up big time. The objectives of root cause analysis. There are three principal objectives of root cause analysis. The first is to discover the root cause of a problem or an event. The event itself is isolated in nature, but you want to trace it, link it to a cause. What exactly is causing it? Why am I having this issue or this manifestation? The second one is to fully understand how to fix and compensate or learn from any underlying issues within the root cause. Because if I'm able to isolate the cause, I would have learned some lessons. I would have known, okay, this is why this is happening, and this was leading to the symptom I am seeing. I could then be able to take appropriate measures, either to prevent a reoccurrence or to redesign, like we looked at in Lesson 1, under Design Out Maintenance. I could redesign, eliminate the root cause, and have a more stable operation. Then to apply what we learn from this analysis to systematically prevent future issues or to repeat our success stories. Root cause analysis thrives on some core principles. And what are the principles? About 6 or 7 of them. Root cause analysis, firstly, it focuses on correcting and remedying root cause rather than just the symptoms. It targets the root cause than just correcting symptoms. The second one is that the second core principle is you don't ignore the importance of treating symptoms for short-term relief. Now, it is important to treat or address the symptoms just for some short-term relief. But it is more important for us to be able to isolate the root cause so that we can be able to eliminate it entirely. So you don't ignore the symptoms, but you go beyond the symptoms to isolating and handling and correcting the root cause. Principle number 3 is that you must realize that there can be and often are multiple root causes. In troubleshooting an equipment, for instance, we said in troubleshooting, you are carrying out a systematic investigation to be able to a logical and systematic investigation to be able to determine or isolate the cause of a fault with the least likelihood of error within the shortest possible time with a view to fixing it. That's troubleshooting, and it takes place in every branch of engineering. In the course of troubleshooting, you might discover that you stumble at a root cause, and the temptation is to quickly conclude that this is why I am having the symptoms or the failure symptoms I have been encountering. But there may be one more than just that one root cause. And so we must realize that there can be two or more or multiple root causes for a particular symptom. And when you have a case of multiple root causes, you must be able to isolate the particular one that is resulting in whatever you are experiencing so that you can begin your maintenance and correction from there. Another one is we must focus on how and why something happened, not who was responsible. In root cause analysis, as much as possible, we don't look at the individuals. We look at the issues involved, how they are happening and why they are happening. We try to be very, very non-personal as far as root cause analysis is concerned. Another principle is you must be methodical and find concrete cause-effect evidence to back up your root cause claims. You must be so convinced, having methodically investigated and logically considered the facts on ground, that when you arrive at a particular conclusion, you'll be able to say with all certainty that this is the cause and these are the effects of this cause, and you tie them together and nobody will be able to fault your claims. Then the next principle is that root cause analysis must provide enough information to inform a corrective course of action. It does not stop at, this is what is causing it. Yes, you have identified what is causing it. How do we solve it? A good approach to root cause analysis will aim at what? Identifying and providing enough information on how to correct the errors that have been able to isolate. And lastly, root cause analysis consider how a root cause can be prevented or replicated in the future. You want to make sure that it does not happen again. You want to make sure that it does not come up again. And so you are correcting what you have seen, or you're also preventing a reoccurrence. It might involve change of components, it might involve change of technology, it might involve some modification, some isolation, whatever you do to make sure that it does not happen again. That is one of the core principles of root cause analysis. Having looked at the objectives and the core principles of root cause analysis, we want to look at the steps involved in root cause analysis. And there are basically 3 steps involved in root cause analysis. Step 1, define the problem. Step 2, collect data. And step 3, identify possible causal factors. I want to look at the steps in details. And they come mostly, what helps you in root cause analysis is ability to ask questions. You ask yourself, you ask any other operator, you ask other technicians that are there, because you want to get information. It's all about information. You want to get as much information as possible so that you can arrive at a workable conclusion that is acceptable and that is effective. So step 1, define the problem. That's the first step. What do you see happening? It may range from the fact that a shaft is vibrating to the fact that you see smoke coming out of that motor, or you see that that side of the electrical panel is heating up, or you see that there's a discoloration somewhere which suggests that there's some heating up that is taking place in that subsystem. What do you see? A good troubleshooter must be able to use his eyes very well, use your ears very well, use your senses very well, and you can only know that something has gone wrong if you know the right operational state or the right operational condition of that particular machine or part of machine. If you don't know what it means for it to be working right, you don't know when something is wrong or it is not working correctly. So what do you see happening? It helps you define the problem. Secondly, what are the specific symptoms? Oga, the machine is now fine, it don't work well. That is not an answer. You want to be sure, okay, what do you mean by it is not working well? You want to be sure. What are the specific symptoms? Is there a vibration? Is there chain jumping? Is there a torn belt? Is there an entanglement? Is there a broken shaft? Is there a cam that is disengaged? A follower that is not working? You want to be sure exactly what is wrong. So in defining the problem you are answering 2 questions. What do you see happening? And what are the specific symptoms? Then we move on to step 2. collection of data. Collection of data. What proof do you have that the problem exists? It is data, the data you are able to collect and generate, that will help you in proving, or that will serve as proof for you that there's a problem indeed. How long has the problem existed? At what point did they start noticing, the operator or yourself start noticing that there's a malfunction in somewhere? You want to be able to establish a timeline. Then what is the impact of the problem? What is the impact of the problem? And finally, under data collection, there will be need to analyze a situation before moving on to look at factors that contributed to the situation. You carry out thorough analysis. You disambiguate it. You break it into as little, every small size of component. You break it into very, very small components, and you look at each so that you can be able to analyze properly and then make your conclusions. So we are looking at 4 things under data collection. What proof do you have that the problem exists? How long has the problem existed? What is the impact of the problem? And then analysis of the situation. That takes us to the final step in root cause analysis, and that is step 3, identifying the possible causal factors. What sequence of events leads to the problem or led to the problem? This one failed, and then it resulted in this one happening, and the other one happened before it finally failed. We want to be sure. What is the sequence? For instance, a roller stopped. That is the first thing that you saw happening under step 1. Now, what led to the roller stopping? In the course of your root cause analysis, you will discover that the first thing that happened was that the drive that is powering, the gear drive that is powering the roller stopped. It was no longer moving. And for the drive to have stopped, you also discover, in the course of your troubleshooting, that the electric motor that is connected to the pinion was not driving. That's why the bigger gear did not drive and the roller would not move. What led to the electric motor stopping? It was noticed that there's some smoke and there's some smell of a burnt coil coming from it. And as a result of it, it just stopped working. So you are looking at the sequence of events that led to the problem, which is the fact that our roller has stopped rolling. What conditions allow the problem to occur? And then what other problems surround the occurrence of the central problem? By the time you are able to painstakingly answer these questions, you would have defined the problem, step 1. You would have collected data, and then you would have been able to correctly identify the possible causal factors for that particular problem. And finally, under root cause analysis, we want to look at the tools to use in identifying our causal factors. What are the tools that we use in identifying our causal factors? The first thing is to use the facts and ask, so what, to determine all the possible consequences of a fact. First, you are armed with a fact. The fact is, there's a bond, this thing I can see. There's a broken sprocket. There's a resistor that is bond. There's a motor that is not working again. It cannot even turn. It is hooked. All these are facts. So starting from the facts, you want to ask your 5 whys. Ask why until you get to the root of the problem. Why did it stop? It stopped because there was no power entering again. Why is it that the power didn't enter it? There's a disconnection. Why is it that there's a disconnection? Is it sabotage, or is it that something mistakenly fell on it or whatever? Why and why? By the time you are able to ask about 5 whys, each answer generating another why, you would have discovered the root cause of the problem. Then you drill down. It's another tool. Either we use the 5 whys or we drill down. What does it mean to drill down? Break down a problem into small, detailed parts to better understand the big picture. You break into small, detailed parts to better understand the big picture. When you hold it as a complete, as one big whole, it will be difficult to understand. When you take it one portion at a time, it will help you to better understand all the issues involved. And then you can get a better grasp of the bigger picture. Then the last tool we use in identifying causal factors in root cause analysis is what we call the cause and effect diagram, popularly known as the Ishikawa diagram or the fishbone diagram. Here you create a chart of all the possible causal factors to see where the trouble may have begun. It's just like a fishbone, or the veins on a leaf. You see the final problem or the problem you are trying to investigate at the end, and then you start isolating and identifying one by one what are the issues that could have resulted in this. The aim is to help you consider painstakingly each of the possible causal factors, and at the end you can narrow down your decision to a particular thing that could have resulted in the problem you are having. So far we have looked at root cause analysis. First, we began by answering the question, what is root cause analysis? And then we looked at the objectives of root cause analysis, which you say are three: discovering the root cause, understanding how to fix or compensate it, and then applying what we have learned to prevent further occurrence of those faults. Then we looked at about 6 core principles of root cause analysis, and we now looked at the steps involved in root cause analysis, which you say are 3: defining the problem, data collection, and identifying the possible causal factors by painstakingly considering the data you've been able to generate in step 2. And lastly, we looked at the tools. And we say the tools, number 1, you can use 5 whys. You first ask a why, and once you are given an answer, that answer should produce other whys. By the time you are able to ask 5 whys along the same line, you will get all the information you need as per the root cause and how it progressed to result in what you are looking at. Or you drill down, which we said is to break down a big problem into very small component parts so that you can, with ease, examine each of the component parts, and then putting them together, you have a better understanding of the big picture. And finally, we say you can use the cause and effect diagram to look at the effect retrospectively from the angle of the cause. Thank you very much. That will be the end of our lesson. Good day once again, and welcome to lesson 8 in our series. My name is Engineer Sonny Oboji, and I'll be taking us through organizational structures in maintenance. Now, maintenance varies in terms of operation, in terms of scale, in terms of approach from industry to industry. And a very important component of maintenance is your ability to be able to organize your workforce to carry out the maintenance functions that are available. And that's what gives rise to organizational structures in maintenance. Organizational structures describe how the maintenance personnel available in a particular workplace are arranged for effective coordination and service delivery. It is one thing for somebody to know what to do. It is another thing for that person to be able to do what he is supposed to do, to put that knowledge to practice in a well-coordinated, in a well-supervised manner. Now, where there is effective coordination, there will be no duplication of roles, there will be no clash of responsibilities, there will be no wastage of time and resources, and then we can galvanize everything that is possible in terms of human resources and other material resources to achieve our objectives in a very, very short period of time and in the most effective of ways. That is why we are taking a good look at organizational structures in maintenance. It explains the chain of command. Who answers to who supervises who. If there's any credit, who takes the credit? If there's any blame, who's going to be blamed for any poor performance? Who is accountable for what? In whose possession do we find what? And so many other questions, and it also helps us to explain the direction of flow of information and the authority levels at which different persons exist. There could be supervisors at different levels. Who supervises who, even though all of them fall into the supervisory cadre? And at what point can I say this man has done his job and this one has discharged the maintenance responsibilities effectively? It may vary from workplace to workplace, depending on different factors. And that's why there's no one size fits all or one type fitting all from industry to industry. It is not a template that you can copy from one place and begin to apply in other places. You sit down, you look at the nature of the operations. For instance, in some industries, they just produce one single line of product. That's what they produce from January to December. And so their maintenance crew size, the level of expertise, the level of experience, and the level of diversity might be small compared to an industry where they have different lines of product and they can easily they may need to modify the machines as they switch from one product to another depending on the demand per period. Also, some industries have a network of branches all over a particular geographical location or spread across different locations in the country, and they might want to use the same crew to travel from one place to another depending on the kind of job and maybe maintain smaller crews on site that will handle some less complex operations. So as the complexities change, you see the organizational structure changing, the size of the industry, the nature of operations, the level of diversity, even the level of competence, all this, and lastly, the availability of funds. A lot has to do with funds. If you have enough money, you could keep a rich population of staff. You could keep so many of them. If you don't have so much money to throw around, you maintain a lean workforce. But what it translates to is that your lean workforce will be overworked, especially if depending on the age of the machinery, the number of breakdowns, and so many other factors. What is the objective of maintenance organizations? Because it all begins from there. The first one is to keep production line downtime at minimum level. Downtime is the technical term that we use to explain the fact that I need this machine to work, to run and produce for me. But because of a fault and a breakdown, the machine is not able to work when it's expected to work. That's the downtime. Now, and the aim of maintenance or a maintenance organization as a major objective is what? To make sure that I keep production downtime at the barest minimum. And I can only achieve this by maintaining the plant and equipment in a very, very safe, effective, and a very, very safe and effective way, and a well-controlled manner. Now, it then means whatever must be done to keep production lines operating safely and effectively has to be accorded top priority. So I want to look at about 5 different maintenance organizations or maintenance arrangements, how staff can be organized and controlled for them to deliver their job effectively. We have the line staff organization, we have the craft-based organization, we have the functional organization, we have the area organization, and then the centrally controlled and area organization merged together to function as an approach to maintenance. To begin with, let's look at the line staff organization. The line staff organization, we have a general supervisor that controls the entire maintenance operation. He heads the maintenance organization. Now, a storekeeper or a payroll clerk could work directly under him to provide support services. The storekeeper is the one that is in charge of the maintenance store, that knows which equipment we have in the store, which spare parts we have in the store, which one came first, and he is in charge of issuing them out, or when the tools and the equipment are returned back to store, he's the one that takes proper record of them. He has an important role to play. The payroll clerk takes a record of how many hours are spent in maintenance operation and every other expenditure that is incurred in the course of maintenance for accounting purposes. Both of them work directly under the maintenance supervisor. But looking at the technical side of maintenance, under the line staff organization, we have the mechanical supervisor who oversees or supervises the line supervisor. So both of them are supervisors, but the line supervisor is under the mechanical supervisor, and then the crew members, all the technicians and whatever, they all come under the line supervisor. So you could have a single mechanical supervisor supervising about 3-4 lines. If it's an industry where you have about 4 lines, this line 1, we have a line 1 supervisor, line 2, we have a line 2 supervisor, line 3 has a line 3 supervisor, and there are crew members under each of these supervisors, but they work particularly in their own individual lines. Then there's a single mechanical supervisor that supervises all the mechanical aspects of maintenance across these 3 lines. On the other hand, we might have a pipe fitter supervisor who supervises all the line supervisors that have to do with pipe fitting and plumbing related jobs. And under them also we have crew members. So you have a general supervisor that supervises what each of the supervisors of the respective lines does. They are accountable to him. He takes charge of the entire plant, while all the different supervisors, according to different functions, report to him based on how they have been able to coordinate their own group. It's a simple arrangement that reflects communication of information along the line from a general supervisor to the first line supervisors. That's the first approach to maintenance organization. Next, we look at the craft-based maintenance organizations. Here we have a general supervisor who oversees different supervisors based on their crafts. So we have an electrical supervisor supervising the electrical aspect of the operations, a mechanical supervisor supervising the mechanical aspect of the operations, a welding supervisor supervising welding and all related fabrication and welding related roles. Then we have a machine shop supervisor. Everything that happens in the workshop, machining, all the operations on the lathe, the milling machine, every other thing that happens in the workshop, even in the hand operations that take place in the workshop, everything is under the machine shop supervisor. Then we have the pipe fitter supervisor that supervises the plumbing and the pipe fitting operations. All these respective supervisors supervising different crafts, they report to the general supervisor. So we have a general supervisor that supervises other supervisors, and the supervisors in turn supervise the crew members according to their particular crafts that work under them. It is patterned after specific crafts. The first line supervisor comes through the ranks of craftsmen. For example, he moves from an apprentice pipe fitter to a journeyman after he has graduated as an apprentice, and then he becomes a pipe fitter certified, then he becomes a crew leader, and finally is a line supervisor. And in this case, since we're talking of pipe fitting, he becomes a pipe fitter supervisor under the general supervisor. The disadvantage is that there's a slow response to emergencies due to the requirement of skills from more than one craft. For instance, if there's a breakdown, there's this confusion that happens in most parts of the industry, in most industries. The operator, for instance, might run to the mechanical supervisor, and the mechanical supervisor eventually comes to site and discovers that it has nothing to do with his line, with his craft. It may be a pipe fitting job. So he now refers him again to go look for the pipe fitter. And time is wasted. Downtime elongates, and delay in production becomes a major issue. So the major disadvantage here is that the response to emergencies is very, very slow. That is why it is modified in most industries. The third maintenance organization I want to look at is functional maintenance organization. Here, this system evolved from craft organization. Work is divided according to the type or function of equipment to be maintained. It is the work that determines the nature of the operation, the nature of the maintenance tasks to be carried out that determines how work is divided. The difference between this and the craft organization is that several crafts are often under one supervisor. So we don't have an electrical guy supervising electrical, a mechanical guy supervising only mechanical. When we have a single supervisor supervising electrical, mechanical, and whatever, in which case we may want to call him a technical supervisor that supervises all this thing. An advantage is that it helps the supervisor to become multi-skilled as his skills cut across different tasks. You know, since he is required to know to some level to be able to effectively supervise them. By way of the structure, we have the general supervisor. Under him and reporting to him directly, we have the planning coordinator and the maintenance engineer. The general supervisor may be the plant manager, it may be the technical manager, or whatever, under which the planning coordinator and the maintenance engineer all report. Then we have the instrument supervisors, crushing repair supervisors, elevator repair supervisor, grinding repair supervisor, electrical supervisor, mechanical supervisor, automobile supervisor. All these supervisors, they all work under the general supervisor. That is how the functional maintenance organizations operate. The next one is the area maintenance organizations. Here we have a single supervisor that is responsible for all maintenance carried out in a specific location with well-defined boundaries. This comes to play, for instance, where the factory or the industry has different plants in different locations. Maybe you have one at, let's say, Agbara, you have another one at Badagry, you have another one at Ikeja, you have another one at Ibado, and whatever, you know. So we have area maintenance organizations because of the different locations that are involved, and each of them has well-defined boundaries. At the head of this area maintenance organization is a superintendent. Superintendent, by virtue of the role he's supposed to play, but nomenclature can change from one industry to another depending on what suits their operation. The planning coordinator, like we saw in the functional, and the maintenance engineer work directly under the superintendent. And then you have, at the more functional level, there's a general supervisor for craft shops, a general supervisor for service shops, general supervisor for area, the general area supervisor, we have the general supervisor for fabrication shops, general supervisor for electrical, all under the superintendent. Then as you come further, you see that under the general supervisors, you have supervisors that supervise different functions. Like under the general supervisor craft shop, we have a supervisor welding, supervisor fitting, supervisor this, supervisor that. All they do is what? They supervise different functions under the general supervisor craft shop. And then under the area supervisor, you may have an area planner. Remember that there was a planning coordinator at the top that coordinates the planning in the different locations. So if we are talking about maybe coming out with a maintenance plan, a maintenance budget for the entire network of industries, it is done and coordinated finally by the planning coordinator that works under the superintendent. But reporting to this planning coordinator are individual area planners that plan the maintenance activities in their respective locations. And then you have supervisors, area A, area B, area C, supervising the planning and reporting to the area coordinator, like that. So essentially, you have an organized setup that breaks down into area level arrangements that are coordinated by a general superintendent, which we may decide to call the national maintenance manager or the national maintenance coordinator or superintendent or whatever. From these different locations, they report to him. And whatever is planned at the national level is stepped down into all these other areas. The next maintenance organization we want to look at is the centrally controlled location. Centrally controlled location. All maintenance is requested through a centrally controlled center. The workers are dispatched singly or in groups. The main disadvantage here must be noted is that it is not responsive. Sorts of bureaucracy and different levels of communication and control is not good at all until the crew is sent out to the field. Because of the cascaded nature of this kind of arrangement, the people or the person in charge of making the final decision over the job might not even be in touch with the dynamics of the job on ground at the job site. And so because he is not there to know how urgent and how important it is, it may take him time, or he may be buying time and delaying, and that delay will cause some serious problem, either a deterioration in the condition of the machine or some serious losses at the job site. So a centrally controlled organization needs lots of work for it to be effective. We have a superintendent at the top, the maintenance engineer reports to the superintendent, but then we have general supervisors according to the different tasks working all under the superintendent and then spreading out to the various functions. The last one we want to look at is the centrally controlled and area maintenance organizations. Centrally controlled and area maintenance organization. Here we have a superintendent at the top, as usual. The planning coordinator and the maintenance engineer all report to him and work directly under him. Then we have a general supervisor, a shop supervisor, a general supervisor again, and then line supervisors work under this one. He uses labor more efficiently than the two acting alone. This is a combination of the centrally controlled organization and the area organization. And the essence of this marriage or this arrangement is to achieve a more efficient use of labor, of the existing labor workforce, so that we can achieve our results more. A crew here is normally of a smaller size than a crew in the area organization or the centrally controlled organization. The crew simply calls on a central pool of specialized craftsmen to meet job demands at peak period, rather than employing a full-time craftsman. What happens here is that you have a smaller crew at the job site that try to handle the maintenance operation. And when there is a peak period, instead of battling it all out alone, they could call for reinforcement or call for help from the center, and they can get the needed support and achieve whatever they have to achieve, after which they will go back to what they used to be. So, in essence, we have looked at different structures that could be adopted by different workplaces in carrying out their maintenance. We say, by way of a summary, that organizational structure describes how you arrange the personnel you have, the equipment you have, and everything, so that you can achieve your maintenance goals. It also helps us to establish a chain of command so that we can know who takes responsibility for what, who reports to who, and who is answerable to who. And it can vary from one workplace to another. We looked at the objectives of maintenance organizations, and then we now looked at different arrangements. The line staff arrangement, the craft-based organization, the functional organization, the area organization, and the centrally controlled and area organization working together. I must reiterate the fact that there's no one size fits all. It depends on what suits the particular needs of the industry in question. And again, there's no law that says you cannot jettison one approach and adopt another. These organizations have evolved over time, and you can modify to get an arrangement that suits you the most. In practical terms, what works for most industries now is to have a team, a functional team, that combines different tasks. So you have team A. It has some people on board that are electrical experts, mechanical experts, fitting and pipe fitting and plumbing experts, and all the other functions. And so when there's a need and the team deploys to site, or is deployed to the site, there will be no need of saying, okay, let's look at this. There's nobody that is competent here. Somebody there will lead the group and the others will assist. And with time, there will be transfer of learning, transfer of knowledge, and you get multi-skilled workforce that can work in any area as far as maintenance needs are concerned. So it's all about how you use what you have to achieve what you need. Thank you very much. That's the end of lesson 8.